Good morning, class 11th. Today we are going to continue our journey into quadratic equations. I've already done one lecture with you on quadratic equation. I'll recap a little bit. In the first chapter, we discussed what a quadratic equation is. Then we talked about the number iota, and we did certain questions on quadratic equation involving iota as well as quadratic equations of the form which were called reducible form from the given form of questions. Today we are going to recap a little bit about quadratic equation. We'll talk about the roots of the quadratic equation. For example, ax square plus bx plus c is equal to 0, where a, b and c are real numbers and a is not equal to 0 is a general quadratic equation where a is the coefficient of x square, b is the coefficient of x and c is a constant term. Now what we are going to do is we are going to show you certain things, like if I take a common here from this equation, I get x square plus b upon a x plus c upon a is equal to 0. In the next step, I will tell you that I have already said that a cannot be equal to 0. So that means this portion, second portion, is going to be equal to 0. That means x square plus b upon a x plus c upon a will be equal to 0. Now, when I have to make, in junior classes you've learned that how do we make a perfect square. It is x square, this is a term with x, so I'll have to create another term. The method is to take the half of the coefficient of x, like b upon a is the coefficient of x here. So what I'll do is we'll divide it, we'll take half of b upon a, which will be b upon 2a, and we will square it and add it to the equation. When I square and add something to an equation, when I'm adding something to the equation, that means I'm changing the equation, but I cannot change the equation. So what I'll do is I will subtract the same thing what I have added. So basically I'm adding 0 to the equation, and that will not make any difference. So what I'm going to do is x square plus b upon ax plus half of this, that is b upon 2a whole square. I have added this. I have added this quantity to this equation, so I will subtract the same quantity from this equation, plus c upon a minus b upon 2a whole square. So when I have added and subtracted the same quantity, that means I am adding 0. I am adding 0 to the equation, and it does not change the equation at all. But I will get the equation in the form which I am looking for. For example, if you look at this portion, this will become a perfect square. Like it will be a square of x plus b upon 2a whole square. The square of the first term, a plus b whole square. Let us, what we have done in expansions and junior classes, a plus b whole square. In place of a, I have x. In place of b, I have b upon 2a. So a square, so x square, plus double the product of first and second term. When I'll multiply this and this, I'll get xb upon 2a. Double of this into 2, so 2 will cancel. I will get b upon a x. And then the square of the second term, b upon 2a whole square. So this is a perfect square. Now I will transfer these terms to this side. It will become b square upon 4a square minus c upon a. This minus term becomes plus, and this will become minus when I have transferred it to this side. Now just look at the equation. X plus b upon 2a whole square is equal to b square minus 4ac upon 4a square. I have taken 4a square as LCM here. When I have taken 4a square LCM, it will remain b square, but it is a will cancel, 4a will remain, so 4a into c. this portion b square minus 4ac, you are aware even in 10th we had discussed that b square minus 4ac is called discriminant. It is called discriminant. So it will become d upon 4a square. It will become d upon 4a square. Now when I will take the square root from both the sides, it will become x plus b upon 2a will be equal to plus minus, whenever you take a square root, you take plus minus under root d upon 2a. The square root of d is under root d, plus minus sign I have written, and 4a square becomes 2a. Now I'll transfer, I want to calculate the value of x. So x will be equal to minus b upon 2a plus minus under root d upon 2a. That means 2a is your LCM, it will come minus b plus minus under root d upon 2a. This used to be the formula which we were using for solving quadratic equation. So you get actually two roots of the quadratic equation. And what are those two roots? X is equal to minus b plus under root d upon 2a, and second root I get is minus b minus root d upon 2a. One with a positive sign in between minus b and root d, and one with a negative sign between minus b and minus root d. These are the two roots of the equation. Now I can write it like this. If I want to write it in the form of equation, x minus b plus root d upon 2a. Suppose this is alpha and this is beta. The second one is x minus this is alpha and this is beta. So x minus alpha, x minus beta, minus b minus root d upon 2a is equal to 0. The product of these two will be equal to 0, because that is how we obtain these. That is how we obtain. I could have brought it to this side like I brought it in this, and a was originally there. A cannot be equal to 0, but it was the part of the equation. Now I can reduce it to the form x minus alpha, x minus beta is equal to 0. I told you alpha I can write in place of minus b plus root d upon 2a, I am writing as alpha. In place of minus b minus root d upon 2a, I am writing my beta is equal to 0. Or I can multiply this, you will get x into x square minus alpha plus beta into x and plus alpha beta. And if you remember, this equation was obtained from ax square plus bx plus c. So both are equivalent equations. Actually these are identities. These are identities and identities are equal. Now it could be ax square minus a into alpha plus beta x plus a alpha beta is equivalent to ax square plus bx plus c. Now just look, if I compare the terms of x square, x and constant, x square has got variable a with it, constant a with it, x square has got a, so it leave that. But let us see the x term. X term, here it is minus a alpha plus beta, and there it is b. So alpha plus beta is equal to minus b upon a. This is one equation. This is the sum of the roots. Sum of the roots is equal to minus b upon a. Similarly, if I compare the constant terms, a alpha beta is equal to c, or alpha beta will be equal to c upon a. This becomes the product of root. This is the sum of the roots. This is the product of the roots. Because we had assumed the roots to be alpha beta. Two roots of the equation were there. One I assumed is alpha. Alpha was minus b plus root d upon 2a, and beta was minus b minus under root d upon 2a. So alpha plus beta I got as minus b upon a. Alpha beta I got as c upon a. Now alpha plus beta means, minus b means coefficient of x upon coefficient of x squared. Now look in the first equation here, ax squared plus bx plus c. What is b? B is the coefficient of x. So minus coefficient of x upon coefficient of x squared. So to remember this, that what is the sum of the roots? It's always minus coefficient of x upon coefficient of x squared. And alpha beta, the product is what? Constant upon absolute term. Sometimes some people call it absolute term, upon coefficient of x squared. Coefficient of x squared. So you can calculate both the things remembering this. Or simply alpha plus beta is minus b upon a, alpha beta is c upon a. I'll have to rub out this portion here. Now if you look at this format here, a x squared minus alpha plus beta x plus alpha beta is equal to 0. This a could be any constant, not only the variable a, not only the constant a, I can replace it by any other thing because it is not equal to 0. It is not equal to 0. So quadratic equation is what actually? X squared minus sum of roots into x plus product of roots. Product of roots equal to 0. In this I can put some another constant instead of a as x squared minus sum of roots into x plus product of roots. So if you are given the two roots of an equation, you can formulate a quadratic equation using this formula. Now we are going to discuss about the nature of roots. Nature of roots. Now we told you x is equal to minus b plus minus under root b square minus 4ac, which we were writing as d upon 2a. This is the formula which we use for quadratic equation or to calculate the roots of the quadratic equation. Now minus b and 2a, it does not matter. Only the portion here, b square minus 4ac, which is under root, affects the nature of the roots. And there are two cases. Number one, if b square minus 4ac is greater than or equal to 0. In this also there are two cases. The first case would be if b square minus 4ac is greater than 0. That means it is positive. If b square minus 4ac is positive, then what happens is that roots will be real and distinct. Roots are real and distinct. different. They will be not the same, distinct. There will be distinct root. If b square minus 4ac is greater than 0, that means if it is positive, then roots are going to be real and distinct. Second part, if b square minus 4ac is equal to 0, then what happens? Then roots are real. Roots will be real only. Roots are real but same. They will be not distinct. They will be same roots. What kind of thing will that be? If equation comes to the form x square minus 2x plus 1 is equal to 0, which is the quadratic equation, because it has got x square term, it has got x term, it has got 1. If I take out b square minus 4ac, what is b square minus 4ac here? B square means square of the term coefficient of x minus 2 whole square minus 4 1 into 1. So it will be 4 minus 4, that is 0. That means roots are going to be real and distinct. So if I simplify, if I find out the values of this, what will I get? Because you know what is minus b, roots are plus minus under root b square minus 4ac upon 2a. But this portion is coming 0. B square minus 4ac is 0. So what will you get? B was how much? B was minus 2. So minus minus plus 2. 2 into 1. So x will be 1. So x minus 1 and x minus 1. X is 1. The value of the root is 1. But if you simplify it, you will get x minus 1 whole square actually. X minus 1 into x minus 1 is equal to 0. So there are two roots, but there are two roots, but they are not distinct. They are the same. X is equal to 1, x is equal to 1. That's what we said. Roots are real but same. They are not distinct. Here roots will be real and distinct if this is not equal to 0 but it is equal to positive. This is the first case. In the second case, I have if b square minus 4ac is less than 0. If it is less than 0 means it is negative. If it is less than 0 means it is negative, and negative under square root will give us a imaginary number. So roots are imaginary here. Roots are imaginary. So there are three possibilities. If b square minus 4ac is greater than 0, then roots are going to be real and distinct. If b square minus 4ac is equal to 0, that means it will be a perfect square. Actually, the quadratic equation which is given to you will be a perfect square. If b square minus 4ac is 0, that means it is a perfect square. You will get equations like x minus 2 whole square or x minus 5 whole square. These are all quadratic equations, but these are perfect square. So roots are real but same. In the second case, if we are saying if b square minus 4ac is less than 0, then roots are imaginary. They are imaginary. Okay, we have a quadratic equation in the form y is equal to ax square plus bx plus c. Every equation, whatever form it is given, represent a curve. This quadratic equation or any quadratic equation actually represents a parabola. It's called parabola, which you will be studying later in your conic section. It is parabola. And what is the shape of the parabola? What is the shape of the parabola? Parabola can be of this kind or could be of this kind. Either it will be opening upward or it is opening downward. And depends upon how do we distinguish that it is opening upward or it is opening downward. The way is, if A is greater than 0, that means if A is positive in this equation, if A is positive, you have an equation x square plus 5x plus 6 is equal to 0. If I plot this, is y is equal to this. If I plot this equation, then I will get this kind of a parabola. But if A is negative, A is less than 0, for example, if it becomes minus x square plus 6x plus 10, then this kind of parabola will be opening downward. It depends upon the value of A. If A is positive, then parabola will be always opening upwards. If A is negative, parabola will be always opening downward. It will be opening downward. It will be opening downward. Now, let us relate it to our roots. In the first case, if you remember, when we were discussing roots, so we said b square minus 4ac is greater than equal to 0, and we said three cases actually. Let me take first greater than 0. First case was case 1. Let me name it as case 1. In case 1, b square minus 4ac was greater than 0, then roots are real and distinct. Roots are real and distinct. Real and distinct. And what kind of parabola you will get? Suppose this is your x-axis, I am showing this to be x-axis, then either this will be of this nature or it will be of this nature. If A is greater than 0, it will be of this nature, and this, if b square minus 4ac is greater than 0, then it will be cutting the x-axis two places, so you will get two different real roots. It is when A is greater than 0. If A is less than 0, then obviously the parabola will be downward, but it will be cutting x-axis at two places, so you will get two real distinct root. In second case, if b square minus 4ac is equal to 0, we told you that the roots will be real but same, not distinct. So how do we get that? If we show it through a graph, then the parabola will be like this. It will be touching the x-axis. It will not be cutting the x-axis. If it is touching the x-axis, that means you will only get one value of x. It is A is greater than 0. And if it is going downwards, A is less than 0, then also it is touching x-axis at one point, so you get one root only. You will get one root. This is case 1 where the b square minus 4ac was positive greater than 0. Then we realized that when we drew the curve of this curve of y is equal to ax square plus bx plus c, we realized that parabola was cutting x-axis at 2 points and we were getting two real roots. But when b square minus 4ac is 0 and you draw the curve of this, for example, y is equal to x square minus 2x plus 1, you give different values to x, corresponding values of y will be calculated, and you draw a curve between x and y, you will get curve of this kind, because here A is positive. You will get a curve of this kind where it will be touching x-axis at one point, and here also it is touching x-axis. And what about the third case? Case 3. If b square minus 4ac is less than 0. If it is less than 0, that means it is imaginary. It is negative. You will be getting, because d was what? Under root d. You get under root d. b square minus 4ac under root. You get under root d, and under root d negative means if it is negative d, then you will get an imaginary number. You will get imaginary number. So what kind of graph will you obtain if you plot that kind of a curve? Now again I am drawing x-axis. I am not showing the y-axis. We are not discussing just now y-axis. What kind of a graph will you get? You will get a curve like this, which doesn't touch the x-axis at all. If it doesn't touch the x-axis at all, that means it doesn't have the real values. When a is greater than 0, then you have a parabola going upward, opening upward, and it does not touch the x-axis. It is above x-axis, or it could be below x-axis, depending upon if a is less than 0, where the curve does not cut the x-axis. So please see all the three cases which I have drawn, because then some people may not be discussing this, but to make it very clear to you that what does it mean that real, and what does it mean that if it is 0, and what does it mean if it is less than 0. So if it is greater than 0, that means if your b square minus 4ac is positive, then your curve will always cut the x-axis at two distinct points. You will have two real roots. But if b square minus 4ac is 0, then it is going to touch the x-axis. It is not going to cut the x-axis. I am showing both the curves taking a less than 0, a greater than 0. If a is greater than 0, parabola is opening upward. If a is less than 0, the parabola is opening downward. Similarly here, if b square minus 4ac is 0, the parabola is only touching the x-axis. It is not cutting the x-axis. That is why you will get only one value of x. So b square minus 4ac is 0. This is the curve. Depending upon if a is greater than 0, it is opening upward. If a is less than 0, it is opening downward. In the third case, if I have b square minus 4ac less than 0, that means it is negative. If it is negative, then you get imaginary roots. And how do I distinct with the, how do I see imaginary roots? This curve will be not cutting x-axis at all. It will be above x-axis, or it will be below x-axis. Okay, we discussed about the nature of the roots, and we took out the roots of quadratic equation. Like x was equal to minus b plus under root d upon 2a, and another root was minus b minus under root d upon 2a, where d is b square minus 4ac, b square minus 4ac. Now if I add these two roots, like we had calculated alpha and beta, this is x is equal to alpha, x is equal to beta. Let me find out the sum of the two roots, like this is alpha, this is beta. If I add them, alpha plus beta, what will I get? I will get minus b plus under root d minus b minus under root d upon 2a. So what will happen? Minus root d plus root d will cancel. You will get minus 2b upon 2a. 2 will cancel. You will get minus b upon a. If you remember, we calculated the sum of the roots to be minus b upon a. And we had said minus coefficient of x upon coefficient of x square minus the coefficient of x upon coefficient of x square. And if I calculate alpha into beta, what will I get? Minus b plus under root b upon 2a into minus b minus root d upon 2a. When I will multiply them, a plus b, a minus b will give you minus b whole square minus root b whole square upon 4a square. So it will become b square and it will become minus b square minus 4ac. It was minus 4ac, so it will become plus 4ac because under root d is b square minus 4ac. So when I'll open negative, from the negative outside we'll change the signs. Upon 4 2a into 2a is 4 square. This will cancel, 4 will cancel, 1a will cancel, you will get c upon a. So you get the constant or the absolute term upon the coefficient of x square. So we get the same values. I'm insisting on these alpha plus beta, alpha beta, because now we will be discussing about them also, and we will be using them quite often, this formula. So we need to understand that what is the sum of the roots and what is the product of the roots. There are certain other relations which I would like to discuss, like alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. Instead of a and b, I have taken alpha and beta because we will be using now these formulas. Alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. Alpha minus beta whole square is equal to alpha square plus beta square minus 2 alpha beta. And you also get the formula alpha plus beta whole square is equal to alpha minus beta whole square plus 4 alpha beta, which can be obtained by subtracting these two equations. Alpha minus beta whole square will be equal to alpha plus beta whole square minus 4 alpha beta. Also, we will be using the cube formulas like alpha plus beta whole cube will be equal to alpha cube plus beta cube plus beta cube plus 3 alpha beta into alpha plus beta. We are using the variable alpha beta instead of a and b. It does not matter. A plus b whole cube is a cube plus b cube plus 3ab into a plus b. Instead of that, what I am using is alpha plus beta because we will be using these terms here. Or this could be written as alpha cube plus beta cube because we will be calculating alpha cube plus beta cube. It will be alpha plus beta whole cube minus 3 alpha beta alpha plus beta. Similarly, alpha minus beta whole cube will be alpha cube minus beta cube minus 3 alpha beta alpha minus beta. So if I want to calculate alpha cube minus beta cube, it will be equal to alpha minus beta whole cube plus 3 alpha beta alpha minus beta. These are all formulas we have to remember. Now if I want to use alpha square plus beta square to the power 2, for example, alpha square plus beta square to the power 2, again in place of a I have alpha square, in place of b I have beta square. A plus b whole square will be a square, that will be alpha 4 plus beta 4 plus 2 alpha square beta square. Or if I want to calculate alpha 4 plus beta 4, that will become alpha square plus beta square minus 2 alpha square beta square. All these formulas we will be using. It is important to remember all these formulas. Alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. Alpha minus beta whole square is alpha square plus beta square minus 2 alpha beta. Alpha plus beta whole square is equal to alpha minus beta whole square plus 4 alpha beta. Because sometime you might have to calculate alpha square plus beta square, so we may change to that also, like I can get alpha square plus beta square equal to alpha plus beta whole square minus 2 alpha beta, or I can also get alpha square plus beta square as alpha minus beta whole square plus 2 alpha beta. So all these formulas interchange can be done from left side to right hand side to left hand side. Alpha plus beta whole cube is equal to alpha cube plus beta cube plus 3 alpha beta and 2 alpha plus beta. Alpha cube plus beta cube will be alpha plus beta whole cube. From this only we are obtaining this. We are transferring these terms to this side. Alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. Similarly, alpha minus beta whole cube, then you transfer an alpha square plus beta square whole square. So we obtain these formulas from this only. Now we will be doing some questions based on this.